In this section, we're going to explore linear equations a little further. We're going to look at how to find linear equations if you're given 2 points. And we're going to look at some other word problems that deal with linear equations. So let's go ahead and get to the notes and start working on them. So we left off last time with some linear equation stuff, and we're going to pick up there for this time. And we're going to start by building a linear equation using a point and a slope. So let's say we are given the following. Let's say we are told that we have a line that's going through the point 2, 3, and we have a slope on that line of -1. And what we want to do is we want to find the equation of the line. Find equation of the line. And in order to do that, what we're going to use is we're going to use the slope-intercept form of a line again. So we have y equals mx plus b. And I've got 4 variables here, and if I know 3 of them, I can find the 4th. So I'm going to look at these, and I'm going to see which ones I know. Well, I know slope. That's -1. So I'm going to plug that in. I've also got this point, the point 2, 3, and that is x and y values, and what I don't know is I don't know what my y-intercept is. So I'm going to plug in the x and y values that I know. It's 2, and it's 3. And now I can solve that equation for b and figure out what my y-intercept is for this line. So this would give me 3 equals -1 times 2 is -2 plus b, and I'm going to add 2 to both sides. So that'll give me 5 equals b. So now I know my slope. I just solved for my b, so I can write the equation for my line for all the other x's and y's that are out there. I use a specific one to start with. Now I'm going to say for all points x, y, they're going to follow this equation, -1x plus 5. All right, so that's how we can find the equation of a line using a point and slope. Now let's look at a word problem that's associated with that. And again, I just pulled one out of the book. It says, according to U.S. Department of Education statistics, in the year 2000, zoom out just a little bit here, tuition at a public 4-year college averaged $3,506 and increased at an average rate of $157 over the next several years. All right, so we've got two data points in here. Okay, we are told that we started out in the year 2000 with this amount of tuition. And then it's increasing at an average rate of $157. All right, so that tells us what we have. What we're going to do is we need to identify our variables first. So our variables are the 2 things that are changing. The 2 things that are changing are the tuition cost. So T is going to be my tuition cost. And little t is going to be the year. But what I want to do is I want to get everything in relationship to the year 2000. So I'm going to say that t is the number of years since 2000. And I'm doing that for a couple of reasons. The main one is it makes my life easier. Because if I say that this is the number of years since 2000, then this value up here, 3,506, is at a t value of 0. So in other words, it gives me a point, and the point is, if I think of my point as t, capital T, my time is 0 years since 2000, and a tuition value of 3,506. And what that's going to be is that's going to be my b value, because that's my y-intercept. If I look at my graph, I have little t and I have big T. Big T acts as my y, so this is where I'm hitting my y-axis. And I have a slope because my increase is an average rate, and the rate is the key here because that's a rate of change. And my rate is changing at $157 for every 1 year. Or we could write that as just 157. Now, once I've got that, notice I can write my equation now. I'm going to use y equals mx plus b, and I'm just going to replace what I'm dealing with. Instead of y, I chose capital T for tuition cost. My m value is going to be 157 because that's how much I'm increasing every year. My x is going to be my little t, which is my number of years since 2000. And my b is going to be my value in year 0, which is $3,506. And there's my equation. Now, you could have chosen a point of 2,035.06 and done the same thing that we did up here, but this is much easier and makes more sense when you look at the numbers, because this is going to be your initial value in year 0, if you think of this as year 0, and this is going to be how much it's increasing every year. Okay, if you do it the other way, you'll get a big negative number here because you're going all the way back to the year 0. All right. Let's go down to part B. It says, use your model to predict the cost of tuition in the year 2007. So what we have there is we have a little t value, our time value, and our time value would be 7 because that's how many years since 2000 we're looking at. I'm solving for my capital T, which would be 157 times my t value, which is 7, plus 3506. And when I use my calculator on that, 157 times 7 gives me 1,099, plus 3506 gives me a tuition of 4605. So that's going to be my tuition cost. Okay? Let's go on to the last page here. And what I want to look at is how to, so last time we did a point and a slope. Now, what would we do if we had 2 points? So let's say we were given that the line we're interested in goes through the points 2, 3, and, or negative 2, 3, can't read my own writing, and 1, negative 4. So those are the 2 points that we want to find a line that goes through. So what I'm going to do is I'm going to start by finding a slope, because if I've got 2 points, I can find my slope using that equation y2 minus y1 over x2 minus x1. So again, it doesn't matter which one I use as y2, which one I use as y1, as long as I'm consistent. So I'm going to use this as my y2 x2. So I'm going to have negative 4 minus 3 over 1 minus a negative 2. So that's going to give me negative 4 minus 3 is negative 7. 1 minus a negative 2 is the same as 1 plus 2, which is 3. So my slope is negative 7/3. Now I'm back to a situation that's similar to that first one that I dealt with, where I have a slope and I have a point. I have 2 points, but I could use either one and my slope and find my equation for my line. So let's do that real quick. And let's just pick this one for the heck of it. So I have y equals mx plus b. I'm going to plug in my y value is negative 4. My m is negative 7/3 times my x, which is 1, plus b. And now I can solve for b. So negative 7/3 times 1 is negative 7/3, so I'm going to add 7/3 to both sides. So b is going to be equal to negative 4. I'm going to change that into thirds, so that would be negative 12/3 plus 7/3 gives me negative 5/3. Alrighty. And so my equation for my line is y equals negative 7/3 x minus 5/3. Now just for fun, let's see what would happen if we use the other the other point. So if we use the other point, y is 3, and negative 7/3. My x is negative 2. And let's see if we had done it that way to find our b. Well, let's see. Let's change that into thirds, so that would be 9/3. Negative 7/3 times negative 2 is a positive 14/3. So if I subtract 14/3 from both sides, 9/3 minus 14/3 is negative 5/3. So I get b equals negative 5/3 again. So it doesn't matter which point you pick, you're always going to get your equation for your line. Now let's look at a application for that. So according to the National Sleep Foundation, in 2000, Americans averaged 6.9 hours of sleep each weeknight. In 1900, they averaged about 8 hours and 30 minutes of sleep per each weeknight. Model these data by a linear equation and use it to predict the year when Americans will not be sleeping at all on a weeknight. Well, notice what we've got here is we've got 2 points. We've got 2004, when they slept 6.9 hours, and we've got 1900 when they slept 8.5 hours. So what I'm going to do is I'm going to set up my my variables. So my variables are going to be h for number of sleep hours, and it's going to be t for the number of years. And I'm going to use since 1900 because that's my first year that is there. And that's going to make my job a little bit easier. Alrighty. So that's going to give me 2 points. That's going to give me, let's see, I've got 2004, which would be 104 years since 1900. And at that point, they're sleeping 6.9 hours. And we've also got the year 0. And in that year, they're sleeping 8.5 hours. I'm going to write that as 8.5. Alrighty. Now, notice that this, because of the way I set this up, this is my b value. So if I can find my slope, I don't have to go through the stuff that I did up here. I have my b value already, so I just need to find my slope. So my slope is going to be my change in my sleep hours. So 8.5 minus 6.9 over the change in my years, 0 minus 104. Remember, if you're picking this one to start with, you have to start with that for both the y and the x. And so what does that give me? That gives me 8.5 minus 6.9 is 1.6 over a negative 104. And 1.6 divided by negative 104, on my calculator, I'm going to get that big old long messy decimal. I'm just going to round that off. So I'm going to say m is approximately negative 0.0154. Okay? So that gives me my y equals mx plus b. Well, my y, I'm using my sleep hours instead, so h is equal to my slope, which is negative 0.0154, times my number, my time value is my x, plus my initial value, which is 8.5. So there's my equation. Now what I'm interested in is the year in which Americans will not be sleeping at all. So that would be a sleep value of 0 hours. So what I'm going to do is I'm going to plug in 0 for the number of hours. Okay, which gives me this. And I'm just going to solve that for t. So I'm going to add 0.0154 t to both sides. Or you could subtract 8.5 from both sides. It doesn't matter. I'm just trying to get rid of the negatives. 0.154t. So that gives me 0.0154t equals 8.5 and then I'm going to divide by 0.0154. So 8.5 divided by 0.0154 gives me a t when I round off of about 552. Now please don't stop there, because what I asked it is the year. Okay, I didn't want to know what the t value was. I wanted to know the actual year. So to find the year, remember this is the number of years since 1900. So 1900 plus 552 gives me the year 2454. So the year 2454. All right, lastly, I want to look at modeling data using a line of best fit. So I want to show you how to do modeling data using your calculator. So I'm going to open up the book here real quick. Okay, so here's the part of the book that I'm looking at. And what they gave us is they gave us 3 points. They gave us the point 0.05, the point 1.59, and the point 8.2. And they say, let's take that and let's see if we can. Notice we have 3 points instead of 2 points. So they're going to be close to being on a line, but maybe not quite. And if you graph those points, you can see that they're close to on a line, but not quite. So what we want to do is we want to put those in. Now they show you 2 ways, or they show you 1 way. I'm going to show you 2 ways of doing those points. So let's see, we've got our points of, let me just write this down on our sheet over here. We've got points 0, 5. We've got point 1, 5.9. And we have point 2, 8.2. Alrighty. So I'm going to go to the document camera now. Okay, so there's my points. Now, there's 2 ways to do this in the calculator. The first way, trying to get this all together. The first way is the way that they showed you in the book. What you can do is you can take and put stuff into lists. Alrighty, so if you notice what they're doing here, back to the book. Okay. They're taking and they're putting stuff into lists, and in order to do that, they're using these squiggly brackets, and they're using L1 and L2. So let me show you how to find those. Okay, so if you look at your calculator here, the squiggly brackets, if you have an TI-83 or TI-84, the squiggly brackets are right above the regular parentheses. And on mine, they're in blue, which means that they're a second function. So if I hit second and parentheses, that's going to give me that squiggly bracket. And what I can do is then plug in 0, 1, 2. And I'm just plugging in all of my x values. Then I close my squiggly brackets. And then I have to put that into L1. So the way I'm going to put that into L1 is I'm going to use the store feature. Store right here. It says let's take that and put that into L1, and L1 is the second function above the number 1. Okay, right there. So that gives me, I've now put those numbers into L1. Okay. Now I'm going to put this second set of numbers into L2. So again, I'm going to do the same thing. I have 5, comma. So here's my comma right there. 5, 5.9, 8.2. And I'm going to close my squiggly brackets and store in L2. And L2, again, is the second function on the number 2. Okay, now those are in there. And now what I'm going to do is I'm going to do a statistical feature. So I'm going to hit the stat button, and I want to calculate a linear regression. And we'll talk more about this when we get into the technology project later on in this section. but I'm going to choose linear regression. Oops. And just hit enter. And I have to tell it where to find my x's and my y's. It wants the x first, so I'm going to hit L1, comma, L2, and then it gives me what my a value, or x, or my slope, and what my b value is. Alrighty. So if we look at that, 1.6 and 4.766. All right, so the same thing there. So that's one way to do it. I want to show you another way that you could do this, and you may have seen this in previous classes that you've taken. Another way you could do that is you could put the lists in through the stat feature. So you could go to stat, and instead of going to calculate, you could go to edit, and here's your L1 and your L2. Now, if you've got stuff in there and you want to clear it out, what you're going to do is you're going to go up and you're going to highlight L2, and you're going to hit clear, and that's going to clear everything out. But in order to execute that, you need to hit enter, and then it'll clear out L2. I'm going to go over, clear L1. All right, and now in my L1 and L2, I'm just going to put my data points again. So I had 0, 1, 2 for L1. For L2, I had 5, 5.9, and 8.2. Once I have those in there, then I go back to the stat feature, and now I've got everything in there. I want to go ahead and do that calculation of linear regression. Now, you could put in L1 and L2, but actually it will always assume L1 is X and L2 is Y. So as long as you've got those in there, you could just hit enter at that point. So that's how you can use regressions on your calculator.